friction. It's a very large load, let's say equals to weight W, and is resting on this surface. Now you want to move this to the left side. Let's say this is a very heavy machine and we just want little bit of linear displacement. For this purpose, a very small size of triangular wooden shape is inserted between the block and the surface, and then it is hammered on this side. And once it hammered, since it's a triangular shape, it can give the elevation to you like this. Then again, because of the self weight, it will move downward. Again you hammer, again it will move leftward. So this is sort of machine, the simplest machine invented by man. That is called as wedge. So this is the same as a wedge, and this angle is alpha, called as wedge angle. We are applying the external force on this horizontal surface and this vertical surface, and the horizontal surface is with respect to the ground. This block will show the cut section of the block. So the block will be like here somewhere. Remember, it's an enlarged view. This is not exactly going to deform like this. So do you have a friction over this surface? And is the external force is acting on this side? And the weight of the block will act downward. The size and the weight of the block is very, very large as compared to the wedge. So the weight of the wedge we normally neglect. It's a very, very small piece of wood. So we'll not consider any weight of the wedge. This weight is W, and this is the external force. Let's say the coefficient of friction equals to mu. So the normal reaction will be like this on the wedge. So this is the ground reaction. We are hammering on this side, so this will try to move to this side, correct? So it will try to move this side, so will the friction will occur this side? Movement will be like this. So the friction will occur this way. So this one is original XY system, this is a normal to this plane, so this angle is 90. This is also 90, and it will pass through the center of gravity of this one. This one is XY system for the block, this one is XY system for the wedge, and this one is normal. This angle is alpha, that is wedge angle. This angle is alpha, this angle is 90 minus alpha, so this angle is, this angle is alpha, 90 minus alpha. So this angle is alpha, so this angle is alpha. Now this is the line which join the center of gravity. Through this, the contact reaction at this point will exist. This is contact point. Whenever we have a contact, at that time, the contact reaction will pass through CG. So we have one contact, that is this point. So this is the contact reaction, and one contact reaction will be like this. Let's say this contact reaction is N. We have one contact at the bottom. Let's say this one equals to N1. Let's call this is N2. We have one friction force is like this. That equals to F. So we are applying the external force to this wedge. So the wedge will move in this direction. So the friction force will act perpendicular to it. So this is the direction of friction force. And this one is a friction force according to Newton's third law. F equals to mu n. And this is F equals to mu n. Mu n2, mu n2. One frictional force on the ground. What is this one? F equals to mu times n1. Correct? We have two contacts. One is on the ground also, and one at the interface. So this one is very complicated to handle. So we'll come to the basic idea about the friction angle. If this is the weight W, this is the normal reaction N, and this is the external force applied F. So is the friction force will act like this, and is this value of friction force is mu N. So if I draw the same figure like this, I have one force like this, one force like this, and can I combine these two forces using vector as this force? What is this force? Is mu N, and what is this force? Is N. So this one is mu N, this one is N, and can we combine these two forces using vector analysis? So is this is the resultant force R, and is this resultant is equal to angle equals to what? Phi. And what is phi? So tan phi is always equals to what? Mu. That you can see from this figure also. Is it correct? Now one important thing is that how you quickly draw this figure from the original figure. So first of all, you draw the rectangle. Then you show the external force. Draw the rectangle, show the external force, and then draw one normal. Is that fine? Is that fine? Then you show the value of R on the opposite side of the direction of force. So will the R will be on this side? Then only the component of this R will be friction force will be like this. But if you show the friction force R like this, is the friction force will act in the same direction of force. So this is not a good idea. So what is the correct idea is to show R. And what is the angle between the normal and reaction? Is it always equals to phi? Correct. Now what happened because of this one? Now the problem is reduced to three forces. One is Wedge, one is external force F, and one is R. So can we solve this problem using Lamy? That is the advantage. But can you solve this problem by Lamy? No. You have to go by what? Sigma fx and sigma fy. So sometimes if you want a quick solution, then you can use this concept. But avoid this concept for the regular problem. Because it is very simple to construct this figure and solve sigma fx and sigma fy. Use this concept only for wedge. Now see my figure. Is this is N1? Is it same as this normal? Is it same as this normal? Correct? Is this normal here? Is it the same as this normal? Is it the same as this normal? Then is the external force is applied like this? If the external force is applied like this, your R will be on the opposite side. And since you are applying the external force on this side, is your R will be like this. So that one component will be this, is same as mu N1, and other component will be like this. Now we are going to call this value equal to R1. And is this R1 is a vector sum of N1 and mu N1. यहाँ तक clear है क्या पहले बताइए? Surface, that is this surface, okay, inclined surface. For inclined surface, this is a normal, okay. Just only show the normal because we have developed the idea about the normal. Agree? Now with respect to this normal, is the friction force is acting like this. Am I correct? So where shall I show the value of R? Shall I show this way? Correct? And is this value of R2, I will call this as R2, is this is making an angle of phi with the normal. I had not said vertical, I said with normal. So this one is a normal to this plane. Correct? Now this normal itself is inclined at an angle of alpha. Is it inclined at an angle of alpha? So is this R2 is inclined at an angle of alpha plus phi. Now see how many forces we have. One is R1, one is R2, and one is F. Can you solve by Lamy? How many forces we have here? 1, 2, 3, 4, 5. Secondly, this is inclined, has to be resolved. This is inclined, has to be resolved. Is it more complicated as compared to this figure? So to solve the wedge, you have to use this concept. What is the principle finally? In the case of wedge, do not show friction force. Do not show normal. But solve your problem by using R. What is R? Is the resultant of friction force plus normal. And this R will always incline at an angle of phi to the normal, not vertical, to the normal. Is it correct? And will always be in the opposite direction of force. इतना याद करिए तो आपका प्रॉब्लम सॉल्व हो गया, नहीं तो फिर वेज नहीं समझता. Step number 1, R is the resultant of friction force and normal. How you going to draw this is first draw the normal to the plane, not vertical. Normal to the plane. Your plane may be horizontal, your plane may be vertical or inclined, but you have to draw the normal to the plane. Step number 2, construct an angle of phi between normal and resultant. On the opposite side, on the opposite side of direction of force, so which is explained in this case. So this is external force, this is normal, so you construct on the opposite side, and do not write normal, just show R at angle of phi. For the inclined plane, this one is a normal, this is a normal. Construct phi in the same direction of force, right as R2, but your normal itself inclined at an angle of alpha. So total angle with the vertical is alpha plus phi. So if your plane is inclined, it's alpha plus phi. If your plane is horizontal, for horizontal plane is phi is equal to 0. We have a block of 10 kilonewton, and this one is the wedge. All coefficient of friction is 0.36. We have one 10 kilonewton block, and we have given the wedge angle equal to 20. Coefficient of friction of all surfaces 0.36. This one is external force P. We want to find out external force P. So this one is FBD for block of 10 kilonewton, and this is FBD for the wedge. Construct XY axis for both. Motion is given by the wedge, so start with the wedge. Show external force F is passing through center of gravity. Show this force as a P. Now first of all, we'll go for horizontal surface. But before this, I will calculate phi. So tan phi equal to 0.36, so phi is equal to tan inverse of 0.36. Now we will go for this surface. This surface is horizontal. This one is a normal to this surface. So you have to construct the resultant R on the opposite side. Actually, it will going to pass like to the center this way. So this one is R1, and this makes an angle of phi that is equal to 19.8. This surface is inclined at an angle of alpha equal to what? 20. Now this is vertical, this is P. So with respect to vertical, is the angle is alpha plus phi. With respect to normal, angle is phi. With respect to vertical, the angle is alpha plus phi. Alpha plus phi. Phi is 20, this is 19.8, so this is 39.8. Let's call this equals to R2. So this R2 will be going to act over the block also. So this is R2. So this angle is 39.8, so this angle is also 39.8. the weight of the block will act vertically downward, passing through center of gravity, 10 kilonewton. Okay. If this wedge will be go to this side, will the block will move upward. So the motion of the block will be upward. Now check this surface. If the friction is going to occur over this surface, if the friction is going to occur over this surface, and therefore there is a friction force. If the normal reaction is like this, so is the resultant will be like this, correct? So this one is the normal surface to this. Okay, motion is this side. So where you going to construct the R2 is on this side or on this side? Will you construct like this or will you construct like this? If you construct like this, is one of the component of the friction force will be like this, and the normal will be perpendicular to it. And if you are thinking that I will construct like this, then is the friction force will be upward, which is not correct. Why not correct? Because the motion is what? Upward. So the friction force will be like this, and then the normal will be like this. Correct? Eh? I have the motion of this block. Is it upward? What is the method? Draw the normal. Is it correct? Draw the normal and show the phi in the same direction of motion. Is the rule like this? Draw the normal and the resultant on the opposite side of direction of F. That is same direction of motion. Is this normal is constructed in the direction of motion? Is this normal? Is this R3 is constructed on the direction of normal? Is this R is constructed in the direction of normal, in the direction of motion? Is this R is constructed on the direction of motion? So you modify this and you can write this also in the direction of motion. Is this angle is 39.8 and this one is 39.8, so what will be this angle? Is this angle is, how much is this? 39.8. This one is 19.8. Is this total angle is 180? So this is 180 minus 39.8 plus 19.8. 120. 120.4. First step is okay. Then I required the angle between this value and this value. Is this angle is 90 plus 39.8. So this one is 90 plus 39.8 is 129.8. Correct chal raha hai? What is the last angle between P and R1? Is 19.8 plus 90, 108. Your sum is 360 or not? If so, then we'll proceed. चलो यहाँ से start करें. We will solve this figure later on because all three are unknown. We'll come to the figure of this top figure. What is the angle between these two? That is this value and this value. Is it 90 plus 19.8 plus 39.8? 0.6. What is the angle between this 10 kilonewton and R2? 90 plus, is it 180 minus 39.8? 140.2. Now remaining angle will be equals to 90 minus 39.8. 90 minus 19.8. This angle is 70.2. Now we can apply Lamy to the block. So according to Lamy, 10 divided by the angle between R1 R2 and R3, that is 149.6. We will only calculate R2 because R3 is not required for calculation. So if you want to calculate R2, you have to write down the angle between 10 and R3, that is 70.2. So what is the value of R2? Now we'll apply Lamy to the figure number, that is for wedge. So we'll start with R2. If you want to write down for R2, you have to consider the angle between P and R1, that is 109. And we are interested in P, so when you are writing for P, you have to write down angle between R1 and R2, that is sine of 120.4.